Today I'm supposed to talk about how to get started with blueprint-based or blueprint-driven formalization projects in Lean. We'll see that it's much more universalizable than that, not just a Lean thing. Yes, so what I did is just I really started first with a motivation, because I've been asked multiple times by mathematics students, mathematicians, mathematics enthusiasts, and so forth to say, okay, but how can I start really my own blueprints-driven stuff? I really want to formalize my lecture notes. I want to formalize my textbooks, or whatever. A new research paper, for example, that happens once for a stochastic analysis paper. And it was quite a mess, in the sense that typically what they do is just, okay, let's see what's been done before, let's copy-paste a bunch of folders, try to customize it in proper ways, and spending about 2 to 3 hours to actually set up the whole thing. So what I did is what I'm doing now is just to I want to lower the barrier to entry to this, and to actually possibly annihilate it with this approach. I will just have to stress first that this is not a definitive solution. If you're interested, I will talk afterwards about a few proposals, but I just want to have a small talk of, I don't know, 20-25 minutes with this hands-on session where I show how this is done. And then later we can discuss about the challenges and so forth. So, okay, so this is actually a follow-up to the talk that happened by Patrick Massot that has been held in a previous workshop, that was called, from informal to formal and back. Actually, here just a sub-part of it, a partial follow-up in the sense that it's only from informal to formal. And I will just say that for now, the only thing that you need to do is just go into this repository, doing the usual things. So clicking on the start button. Oh, okay, I'm kidding about that. And then trying to follow these instructions, okay? Because I try to be as detailed as possible. This is just for people that are not supposed to know anything about Git, anything about Lean, anything about GitHub infrastructure at all, okay? So how do we do that? Well, we read this, we just make sure that we have a Lean installation, of course, that is working, and then we use this template. So what it means is that we just click on this green button here, use this template, create a new repository, right? And then it generates a new repository that I can call, I don't know, new Lean project or something. And then leave it public so that you can click on it later. Okay, so now it's generating a template. You might ask, what is the difference between a fork and a template? Well, the fork is supposed then to contribute something to the original repository. That is just a way to start up. Okay, so now that we've used this template, we just need to configure GitHub Pages, which is very simple. We just go to the settings, then Pages, and then we activate the GitHub Actions from here. Okay. Then what I want to do a little bit is just to give a very brief exploration of how a typical collaborative Lean project is structured, in the sense of what is this folder structure, what is these files are doing, just a little bit. So as you can see, we have the .github folder with the workflows and the CI integration and stuff. We have some VS Code, configuration settings that is kind of to have your VS Code setting kind of monthly quality and so forth. And then we have the typical big project folder where all the code is actually stored, and a few scripts about how to properly and in development mode update Mathlib and the dependencies of the project, and then a bunch of other things that are quite well described here, but please, if they're not clear, come to me later and I will explain everything. So now, the very simple thing that you need to do when you use this is just to clone, and again, I'm using no CLI for GitHub, just using GitHub Desktop. That is probably the most used for the typical user. So I'll just clone this locally, and then start just customizing this template for my project, right? So what I do, I just open the README, I put in some way that is a little bit more readable, and then I open up this terminal, and I read what I need to do, right? So I just customize this template properly, so I just go to the...
Can you make it bigger?
Oh, sure. Is it better?
Maybe one more?
Sure. How about that?
Like, if you're going to use this background,
Oh,
just
great.
this.
Is it okay?
Yeah.
Cool. So when you do, these are just clickable, so you just go here and replace, you know, all occurrences of the proper project that I made, so it's very obvious. Do this, and you save your file and go back to the tutorial and said, oh, there is a project folder, let's just call it new project. No, sorry, what was it? Yes, let's call it new project. It was new lean project maybe, but let's call it new project. Okay, what I did in the lint, I called it...
You call it nothing.
Oh, okay, sorry. Okay, all right, so project, then new project, okay. Okay, then after that, again, following this, you just go to the example.lean and you just, you know, put, of course, your actual scripts, lean scripts. Then there is a contributing guide that you just customize. And then I'm using a still, I'm sorry, an old-fashioned kind of a lake file.lean. Is of course a template that I will maintain. So the next version will have the more modern and user-friendly lakefile.toml. But then you go here and you just do the same thing with project. Oh, sorry, for view. But again, project, and then very simply, new project.
The project in package.
Projects, it's also
Excuse me?
alpha package, there is some strange string.
Oh, thanks. And new project. Okay, fine. This is still to be saved. Okay. Okay, then of course I change this one with new project. And that's basically done, right? So, okay. So now what I want to do is just to say, okay, so now the lean thing, okay, is kind of properly set. What I really want to do, and what I've been asked by Professor De Pijper was actually, yeah, but how this blueprint actually works in practice, right? So first, I will really showcase a few examples that will be interesting in my view for the discussion because of different projects, all of which I've contributed something to, and therefore I can really speak a little bit more comfortably. But they're very, very different in style, you know? They've been done in different points in time, of course, but then some are very big projects. So there are many project types. So there are big projects, online projects, local projects, like the one in Bonn here, the Bonn Collaborative Formalization Seminar Series in Analysis, right? And so there is very big project like the Carlson or the Fermat's theorem. And then we have projects that are actually trying to formalize something that is already been proved, something that is in research mode, right? So there's completely different objectives and completely different project managers, right? So for example, this PFR project was led by Terence Dow, you know, and he, you know, wrote the entire blueprint, and it was, you know, quite a pleasure to work with that, try to prove some of the lemmas in the proof. Was very detailed. Then we have, you know, but something like Fermat's theorem, which is a theorem that is already, you know, improved, already not part of, you know, modern research. And some of these projects, and we will see it later with the dependencies, some of these projects actually are related. What do I mean by that? Well, that Fermat's theorem was proved by us, by a team supervised by Ricardo Carrasca in Marseille in March. And these projects was done precisely because it was one of the dependencies of Fermat's theorem, right? So, and you will see later how is actually we develop this, how is actually we coordinate in Zule to do this, how the pull requests are done, how people actually bump Matlib and then use it in this project so that it's not necessary in the blueprint anymore. Okay, but another interesting thing is that many of these projects, so none of these projects use the same blueprint technology. So for example, and we'll see it later, for example, the prime number theorem and more, led by Alex Kontorovich, uses a slightly different mode that you will see later from the standard one, in a sense a more literate programming-like mode for the blueprint that you will see. So there is a lot of variation here, and also variation in the quality of the work, because for example, the entire blueprint of the FLT3 project was written by me for a course project, and I really tried to be at the most pedantic level, you know, where every single lemma in the blueprint, in the lean files were actually informalized back. Because we were in Marseille, we proved all that without any blueprint, of course, so it's all kind of a bit more chaotic. But then I manually, just to familiarize with this tool, informalized every single statement, and therefore it's really not optimal for readability, because you will see a dependency graph if you check it out. I mean, you'll see a dependency graph that is completely not at all organized and kind of a mess, right? Too many nodes and with too many entries between them. Then, of course, if you really want to use the lean blueprint, you know, the lean blueprint is a Python package, so you need to have at least a properly installed Python and a package manager pip. So at that point, if you already have, and I will do it here, if you already have Blueprint installed, I always recommend upgrading it. Why? Well, because yesterday I was just chatting with Patrick Massot, that I thank you very much, because we very quickly and rapidly just reviewed a few of my pull requests that I made during this workshop, and added a few new things to the blueprints, and he released on the PyPy, so the package manager, the new version of Lean Blueprint. So now if you install, you have the new version that I will show you today. So just one day old. Okay, so let me just, let me just copy this and show if it actually have. Okay, great. And then how am I supposed to configure this blueprint? Well, it is extremely simple. You never need to leave this command line interface, because yes, because it's been designed precisely for this reason. So let me just try to see if I have this. Okay, you click on it, and then you say, oh, there is an error. Why? Well, because the blueprint wants you, if you want, this blueprint CLI wants you to first commit everything, all changes that you've done before starting the process. Okay, so what I do, I say, okay, I just commit all of that. Okay, so update, let's say, and commit and push from here. Okay. Then again, let's do lean blueprint new, and it asks you a bunch of questions. Many of them with default values, like, what is your project title? I don't know, I have no creativity, so let's do like new project, of course. And then say, oh, who is the author? And it automatically reads your username and its attached complete name. So in this case, Pietro Monticone seems fine. And then, of course, it asks you a bunch of questions that the default option is such that the default option is perfectly valid, like new link project, and then the project website if you want to store it. Where store the API documentation and stuff, and then a few features for LaTeX. So what is the documentation class, right? You don't need to write it by hand, just report is perfectly fine, but you can choose whatever you want. Paper is fine for me, okay, but you can choose. And then there are a few settings for the web version, like if you want to have the tiny kind of window for the proofs that are expandable, I say yes. Some table of contents, you know, what is the depth? I will adopt the usual default option, which is quite good. Same thing for the next few lines. But at this point it says, okay, so the configuration is quite completed. Do you want to create the blueprint? Now let's notice what happened here, right? So I have no sign anywhere here of the blueprint because it's not been created yet, just configured. Now let's create it by saying yes. Oh, sorry. By saying yes. Okay, and it asks something. It asks, well, do you already have the two really everything, right? Do you have the dependencies of the blueprint? Well, actually, no, right? Because let's say no, right? So I don't have these what is it, the check-decal library, which is a small library that take into account if the declarations actually match. The answer is no, so I really want to actually remove this link manifest. That should not be there. I will change the manifest later. Okay. And so I say, okay, yes. And it takes a few moments, and it will add that to this file. So the link file will actually include a new require line. Here it is. And then after that, I'm going to say yes also to the documentation, of course, because I want that. Same thing, same process. And then I just have to wait a little bit more. Good. So, and here is another very important point, right? Because previously I said that there are many, there have been many type of link projects and link project managers and stuff. And this is one of the different components, right? Sometimes you want a project to be online, fully publicly accessible, that the best, you want as many people as possible to contribute. Well, in this case, maybe a homepage might help, right? And so, but in many other cases, if you're just trying to collaborate with your own class, that's not something that you need. You don't want to clutter your repository with that. Good, so let's just say yes in this case, we want the full-fledged version. And so it asks you everything, like homepage title, well, new project is good. Or maybe not, maybe just say new Lean4 project, that's Seem Human. Okay. And let's say the on-page subtitle, which is kind of new formalization project.
If you want it to be empty.
In Lean4. Excuse me?
If you want it to be empty.
Oh, if you want it to be empty, that's a good point. Thank you. that should be actually, I think, well,
Space maybe.
Yeah, maybe, yeah, exactly, maybe a space should be enough, yes. Yes, but I don't want it to be empty, so formalization project in Lean4.
Something is wrong.
It's a formalization project.
Oh, sorry, that's a typo, kind of wanted. And then, do you want that Jekyll theme? I mean, yes, I mean, we will take care of that and update with new blueprint releases, so that's not very much of a problem. And at this point you say, okay, so do you want to configure the CIs, right? That actually on push events and also on manual dispatch will generate the blueprint, the website, and the whole thing automatically. So of course, yes, we want it, right? And it will generate this blueprint YAML file here, right? You can inspect that if you're interested. And if you want later, I can answer all your questions. And then, do you want to commit to repository? Well, in the sense I don't want to do it, but I will commit the whole thing just with another update stuff here. Okay, so that seems to be quite simple, right? Here are all the instructions, by the way. But let me just see what that means, because, okay, let me just see what that means first. I have this new link project here. I just go to Actions page, and it should work, but live demo sessions are not always the best thing. So it's supposed to work, and once it works, it should actually look like, let me see here, should look like this. Oh, by the way, if you want to activate that so that everyone sees it correctly, just go here, you click here, use GitHub page website automatically, and then here there is a 404 of course now, but once the action is finished, it should be produced. So in this case, with the project already proven, this is kind of the minimal web page with a title, with a subtitle, and all these different links to the different subparts. But as you can see, there are some useful links. And typically, this is very good because this is how we actually, at the moment, it's not perfect, but at the moment we coordinate. We coordinate on Zulip, typically on a specific channel, right? And I can show you here what I mean by that. I mean, I can just open this and we have some channels that we work like. If you're working across some project, here is this channel. Here's, for example, the private one, because again, it's a local collaborative formalization in Bonn. Then you have FLT, which is public, and then like PFR and prime number theorem and stuff like this, right? But I think that Zulip is very interesting because I really want to show you how is it that we cooperate really, right? A few examples, like, let me just check it out. Yes, so these are the different repositories. You see the repositories of all these projects are quite similar. But then then, for example, on Zule, so it actually works. So, let's see. Anyway, if you go to the, let's see, if you go to, for example, the Carlson project, you will see that their structure is quite similar, even if it's not exactly identical, meaning that we have these waves of outstanding tasks, which is just a list that you find here at the, written typically by the project manager or the author of the paper. But what is this? Well, this is just a list of tasks that have been formalized, whose statements typically has been formalized, right? And require someone, to prove it. And what happens here is that we just claim some tasks. So for example, I claimed the 7 and 4 task, right? I'm actually working on it. Sorry, Floris, not finished yet. But typically what happens is that people, right here say, oh, this is ready, or I claim that, etc. And this is probably, as you will see in the discussion session, not how it should work. Probably is not optimal, right? I mean, there might be some more automated, more workflow kind of thing to, to cooperate a bit better.
If I understand it correctly, to now, this is just, I thought that was for when you wanted the project to be public and for everyone. Or even if I want one just for my particular paper and I don't want everyone to see how incompetent I am, I don't have to do that.
Yeah, exactly. You don't have to do that. I'm just talking about the collaborative aspect. But if you don't want the collaborative aspect, as I've showed it before, when you do use template, you can always create the private repository, right? The website will always be public, of course, because the GitHub IO page. But unless there is some, kind of conspiracy that really would like to know, exactly your project and steal your thing, I don't think that's a very bad problem. But if you don't want a web page, you just click no when it's being asked and prompted to you, so that's not a problem. Oh, sure.
So your README missed that you need a GitHub login. I mean, you say this is for people who don't know Git and GitHub.
Oh,
so,
you're totally right. I will change that. Thank you very much.
What if I'm like Jeff Brown, maybe, and I don't want to be involved? I just want things on my local machine, and I'm totally happy there. And GitHub is out in the cloud, and I don't trust the cloud or don't want the cloud. Is it possible to use this technology just locally?
Yes. It's possible to run it locally. Yes, definitely. I mean, when we test stuff in development, we always run it locally, and then eventually test it.
There being a GitHub account.
Absolutely. I mean, you both build the link files locally, and you build the documentation locally, and you build the website locally. So you just can test everything. Sure. But then again, as you pointed out, so this is collaborative projects. Sometimes you just want to work on your own. You don't need all that. That's fine. The blueprint can still be very valuable because, of course, you might happen to have your lecture notes already written in LaTeX, right? And you just want to maybe copy-paste some section and put it and increase the level of granularity or detail, or decrease the level of abstraction in something, and maybe design different distinguished and modular tasks for your students to actually have to. That's the point. So sometimes that is not. I mean, this is, for example, PFR, just to have an idea. I mean, let's see. Okay, so this is the extended version, let's say PFR 2.0, right? And yes, again, so we have these tasks, each with its own link to the specific link declaration, and then you can start from that perfectly autonomously, once you claim that, of course. In particular, I would really like to say one thing about for example, PFR project, because it's a little bit special. This project has already, when I started working on it, only on the second version, has already had another Lean project as a dependency. That's quite unusual. So, for example, Carlson project doesn't have any Lean formalization project, ongoing or finished, doesn't matter, but as a dependency, right? Just Matlet. And what happened was that since there are many projects in parallel, there were some tasks in some of these tasks, for example, like Gibbs inequalities and stuff, that were already exactly being formalized. Actually, we've been formalizing in a strictly more general version in another project, in this case the testing lower bound project, which is a completely different type of project, since it is a more private project with 2 people working on it, right? a supervisor and a student, okay? But they working in probability theory, information theory and stuff, they had exactly that already, you know? And again, this is another workload issue that we're not sure how to solve. So we had some ideas, Lorenzo Luccioli and I, as you can see, we already tried to solve this problem by, you know, playing with the lake file and so forth, etc., and see how it can be made. But if you think about it, each of these projects has meta dependencies, right? Because each project depends upon Matlib and are different versions of Matlib. So, you know, the incompatibilities, as you might perfectly well imagine, can be crazy, right? I mean, you need to have either the same person that bumped Matlib both in the first and the second project, or it's going to be quite hard. Of course, another suboptimal way to do things is just to, you know, copy paste that, try to make it work with the notation stuff and conventions. But it turns out, I had written here exactly. I mean, since this is, I mean, a slow project, you know, the OPFR has already been done, so this is just an improvement. I mean, we can really use the. He said that we could use this as a playground for precisely this type of infrastructural, to solve this type of infrastructural problem. So how is it if you have, you know, 3, 4 projects? How do we scale this up, you know, in a way that is feasible, that is doable, right? And instead, the prime number theorem is quite unique because it's the only one among this that I know of that uses the blueprint in a different way. So instead of having, as you can see here, right? Instead of having this organization with a blueprint with all this template tag file, the print tag for the PDF output, and so a richer kind of preamble, the web version for the, again, of course, for the website with a smaller, you know, less rich preamble. What it does, it actually has a tool. I probably prepared it here. Yes, it actually has this. Oh, sorry, should be at least this. Okay. Is this lean blueprint extract tool, and what it does, as you can see here, there are no contents involved, right? Just a bunch of requirements, a few things, but no real content. So what is happening? Well, it's written here it's explained here in this tutorial of how this tool works. But basically, what you find is that if you take one of these lean files at random, you will see that the actual text is precisely before each individual class instance lean declaration in general. So what happens is that, has its own downsides, of course, because as you can see, there is no syntax highlighting. It's kind of, you know, it's just a very small tool, you know, a small folder with a script that extracts, you know, lean code from there and try to do this. I mean, it's not really, you know, it's still in the development phase, but they did that because they found out that the GitHub Copilot worked much better this way. Because much better at auto-completing some tabs and whatnot, right? So because you have exactly the lean version before, you have the LaTeX syntax, and for how these tools work, that I don't know anything about LLMs and stuff like this, but they claimed that they were quite facilitated in their formalization procedures by this. So even if there is no syntax aligning and stuff, they really believe that that was worth doing. So yeah, and let me just show a few things because, you know, in order to respond to respond to Professor DeFive about how is it that, because Professor DeFive started by asking me like, okay, but suppose I have a lecture notes or some project and I want to do something very simple. So I have a definition lean. I want to use this definition in another definition. I want to have them linked by this dependency relation. How do we do that in practice? So, okay, so I can use, for example, Carlson, and I will show actually all of them because it's slightly different, and I think that you will want to see everything about the blueprint. So, let's say, and yeah, so for example, this is a 16 contributor project, so quite big, right? So you have the web page of the project, which is this one, and then you go to the usual blueprint website, right? You have your usual stuff with this kind of, again, very different, very sui generis structure. But then you have the dependency graph. Okay? Now, let me just zoom a little bit. So, how is dependency graph to be interpreted, actually? So, as you can see, first of all, a bit of a legend. So, everything that is square here, okay, there are no definitions, but okay. Is it true? Is it true in? It's certainly true in FLT. So let's open this one too. Okay, where's the website? Yeah. Okay. Blueprint. Dependency graph. Great. Okay. Okay. So here we have a bunch of colors, a bunch of shapes. What they mean. So first of all, these square ones are definition declarations. The ellipses are statements, so theorems, lemmas, corollaries, propositions, and stuff. And so the border always represents statements of sorts. So if it's a definition, of course, a definition. If it's a theorem, it's a statement of the theorem. So, and they have different formalization status. So if it is orange, that means that it's not ready. And in order to do that practically, you just add a command, a special command in the blueprint called /not ready within the environment of that thing. So if you begin definition, not ready, and definition, and your stuff. Instead, so the border signifies precisely that, while the background instead tells you about the formalization status of proofs. And so if you have something that is blue, for example, it just means, as you can find it in the legend, is a blue background. It's just that the result is ready to be formalized. If it is white, instead, it is not ready. Now, again, you will find some blueprints in which this is homogenized. So also the background is orange and stuff, but this is a different version. So again, you have shapes for statements and proofs, and then for formalization status. Of course, the green, if you have a green background that is light green, it means that is in fact formalized. The proof is formalized, but its own dependencies are not. Okay? There is at least one dependency of that has not been formalized. If instead it is dark green like this, it means that all these dependencies are formalized. Okay? Good. So okay. So you may say, okay, but where do these names come from? Well, these names are nothing but the usual LaTeX labels in declaration environments, like begin definition, label that. These will be exactly the names that you find here. Within each declaration, and I can maybe show one of it just to, or the, let's see. Okay, so source, chapter, unfortunately it's only one name, okay. Well, as you can see here, let's take one at random. You will find, yes, like begin proposition, oh, sorry, that's it, okay. You'll find something like, begin proposition, then you have the name of it, the label, and the name, of course, the LaTeX syntax. But then you find some strange special commands like lean OK. Lean OK tells you exactly that that environment has been formalized, right? So if this environment is a declaration environment, it is a statement kind of environment, then you have the border that lights up in green. If it is a proof environment, then it lights up in green the background, right? But then you have also this fun lean command. And this lean command, what it does, it takes as an argument the precise lean declaration, right? So this guy here is something to be found here. Okay, so you have this theorem. Okay, this theorem, as you can see, has been formalized both in its statement and in its proof. And so when you go to the, sorry, there's a link for you here. When you go to the to LaTeX, then you will see that also its proof has been formalized, right? And then, but then you will say, well, wait a moment, what is this uses thing? That is exactly what Professor De Paiva asked for. So this is the command that says the following. Let's take two LaTeX declaration environment, two definitions, theorems, definition of theorem, whatever. And then if you just write \uses and the name of the label of that environment, it just connects them through that arrow. Now there is a fundamental difference in the sense that if you connect a definition into, so a statement to a, you can connect everything, right? A statement to a proof, etc. And if it's being connected to a proof, you will find out that in the dependency graph that just show up as a solid arrow. If you do in declaration, it shows up as a dashed one. That's just very configuration thing, right? That's not super interesting. Okay, so I also talked about a few challenges. I think it's perfectly. Sorry.
Just to clarify, so there's currently like no way to automate this like connection between the text document and the formalization. Right? Everything is done by hand, right? Or
Yes. Yes, at the
is
moment.
that coming or is that not possible? Like I have no understanding of how technically challenging that is.
Yeah, exactly. That's one of the things I would like to discuss with you, etc. Because there are some ideas and so forth, and I'm not even sure. I think that it's even controversial, but I'm not sure about that. But it's possibly controversial the fact that we want that. I don't know because there are situations in which you may not. I'm not sure. I remember some conversation about that, but I don't think that it's been solved at the moment.
Yeah. So yeah, I spoke with
You
Patrick
remember?
about
Okay.
this. So
Marius mentioned.
This is supposed to represent sort of like morally what the dependencies are, and that often, okay, so one thing is you can look for uses of a label, like by theorem whatever, we do yada yada, and then that reference maybe tells you some information, but then you might be doing forward references or other things like the labels themselves inside the LaTeX proof don't one-to-one correlate with actual dependencies, and then also maybe the actual there might be dependencies that are not reflected in the text, like almost, people often reference previous theorems, they almost never reference previous definitions.
Exactly. And then there is another point, for example, many times in real, informal, natural language textbook and material, what you do is not really specifying every single one. You will not say in the LaTeX equivalent uses just one statement. Many times what happens is that multiple declarations get subsumed within the same one, right? And here is an example of what you should not do. This is my own FLT3.
So I mean, the dependency part is like clear. I think clearer to me because of these issues. But like, that's it in OK. Like, is there a way to have if you generate a term that it automatically like fills in this thing in the? Like,
oh yeah, that is definitely something.
That is already true.
No, it's not true.
So yeah, lean OK it's a technical limitation, and there are work ongoing to try to resolve that.
Yeah, so that is one thing that is something that we
So you mentioned you have solid arrows and interrupted arrows?
Yeah, exactly. So look at, exactly. Thank you very much. So this solid arrow, what it means that you use this statement, okay, so I mean this theorem in the proof of the other one. So it's a deductive dependency. Instead, in this case, we have this definition. It should not have been done this way. But as you can see, for example, here, like solution, there's when you click, you take this very bad stuff. Sorry, you take a dashed arrow when you either you use basically a declaration within the statement of another declaration. So what it means is that this definition appears in this one. You see?
So the difference.
Let S be a solution, but of course this is what should not be done. So we're actually I mean, this is something that only in this very strange case of to be very didactic and pedantic, I did. I mean, just to.
So the difference that we try to convey with that is like because with the colors of the boundaries, you indicate can you already formalize the statement? Are all the ingredients there? All the definitions that you need to write down the statement of the lemma, are they there? Okay, then you can formalize the statement already. But maybe to formalize the proof, you need much more.
Yeah.
And so the different kind of arrows also try to convey that kind of.
Wait, so if a theorem or if a definition is used in the proof but not in the statement, would it get an arrow?
Yes, it will get an arrow, and if I'm not mistaken, it will get a dashed one.
Yeah, that should be a dashed one.
Yeah.
So you need all the solid dependencies to formalize the statement, and the dashed one. In addition, you need the dashed ones.
Yeah, I mean, because sometimes you have something like, by definition, and you want to say what exact definition there is here, right? So just how crazy that was, I mean, I really, even something that is already MATLAB, I've included here. I included many MATLAB stuff, so it's what you should not do. But anyway, so I said about this, and then maybe the last thing I want to say is the fact that.
Just one question over there. Why do you have something kind of hanging out without any connections?
Oh, cool. Well, that thing is something that, as you can see from the blue border, is not ready as it's not being formalized even in the statement of it. It just, there is something similar to that. Actually, you can see, you can click here and you can have the LaTeX, which is exactly.
But you know that you need it eventually, is that?
Yes, but you don't. You have an empty. You have no uses, no proofs, no relation with anything. So
what this means is that this blueprint needs some work.
Yeah, exactly.
Because it has to be connected to the rest of the time.
Yeah.
This is a plan.
Yeah.
Okay.
Exactly.
I mean, you could have a blueprint that's formalizing multiple results.
Sure, you can have multiple connected components.
Yes, but just to have an example of the aggregation I was talking about before. I mean, there are many of these. I don't know if I find it one very rapidly, but many of the. Let's see, in Carlson, I believe there are a bunch of this. So, Carlson is here. So you have a lot of. Okay, so already here, you see that is uses and a bunch of other stuff. I just wanted to showcase one example.
Where it uses gives you the edges in the graph.
Yes.
Do you want to say you have something where you have lean with a list of, like one LaTeX result can refer to many lean results.
One LaTeX, exactly.
That's
exactly what is going
Oh,
on.
no, like in the lean command here. Here, there's just one.
Oh, in the link. Oh, okay.
the fact that uses is the list is not surprising.
Yes. Okay, so that's cool. Thanks. So sure. So there are a bunch of examples like this.
Search for backslash lean and then
Yeah, exactly.
regex with a comma.
Maybe this one. Okay, this is an example, right? So we have a bunch of stuff, bunch of auxiliary propositions. Actually, I'm working precisely on the one that is not even there because it's used into finset.measurement.byunion.union, etc. So this is the thing. Last thing about the template is just that I will of course continue to maintain it and increase the automation and stuff. And one thing that I really would like to do is to add an update continuous integration, a GitHub action that basically goes. Let's say if I an example, where's my lean template? Here it is. So here in the GitHub GitHub workflows, as you can see, there is already some dependabot.yaml. What it does is just check for if it's possible to update the GitHub Actions dependencies. So if in any of the workflows here there is some uses action whatever, it checks every month. I've set up, but you can set whatever you want. If there is some new release version, etc., and it automatically opens a pull request, runs the whole GitHub action, and then gives you, yes, it passed, it didn't pass, and then you can choose to merge it. I would like to do exactly the same thing, and it's possible, already written it, but it's not finalized, for the update, for lake update. So, because I think that many times there is just a person that has to go there, and then, no, I think that maybe every week there might be some good bump of Matlib, and then if he fails, you know that he failed, and you don't have to try it out manually, right? Okay, so that's, I believe that's it. And I'm ready for your questions, challenges, and criticisms, and proposals, whatever. Thank you.